In question number 7, they tell us we have a right triangle, and they tell us side AB is 13. They tell us BC is 12, and they want you to find the missing side. So basically you're going to do the Pythagorean theorem, and the biggest thing to remember is the hypotenuse is always the C value, the longest side. So for this one I just did the Pythagorean theorem and simplified, and I found the missing side was 5. At this point, if we wanted to, we could find the area or the perimeter of that triangle. In number 8, it's very similar. They ask which of the following sets could form a right triangle, and to choose all that apply. So in order to be a right triangle, it has to work with the Pythagorean theorem, meaning when I plug in the two legs and square them, I should get the hypotenuse squared. So I'm going to show you what that looks like and circle the final answers. So for question number 8, I just did the Pythagorean theorem for each one, and you can check on a calculator that if you do 10 squared plus 24 squared, you will get 26 squared. They're the same. But if you try 3 squared, which is 9, plus 9 squared, which is 81, you don't get 11 squared, which is 121. So B didn't work. Also, 8 squared plus 9 squared does not equal 10 squared. But 5 squared and 12 squared, when you add them together, you do get 13 squared. So the two that work are A and D. In question number 9, it's very helpful to know some Pythagorean triples to know what would work. So basically in number 9A, it's saying if you add 3 squared and 4 squared, what number would work? And it turns out that you will get 5. So 3, 4, 5 is a right triangle, kind of like what you see in question number 11. In part B, if you double all those numbers, a 6, 8, and a 10 also form a right triangle. A 10, 24, and 26 would be another Pythagorean triple and would work if you did 10 squared plus 24 squared. You'll get 26 squared. And another one to have just in your brain real quickly is that if you have an 8 and a 15, the hypotenuse will be 17. In number 10, they ask us for the length of AB, and the first thing to note is that one side is 20, and they have this little mark, so this has to be 20. Also, it's like half a square. And if you know your special right triangles already, you know that the hypotenuse is a little longer. It's 20 with a square root of 2 every time. Choice C. In question number 11, they ask us for the cosine of B. So first I wrote SOHCAHTOA. Hopefully you know to write that so you know when to use sine, cosine, and tangent. And cosine, first of all, they want angle B, so I'm going to mark angle B. That's this angle right here. Cosine is always the adjacent side over the hypotenuse. So the adjacent is a 4, and the hypotenuse is 5. So the answer is C, 4 over 5. In number 12, they ask us to find the area of a rectangle, and hopefully you remember that's base times height. So when I looked at the triangle, I saw that the diagonal was 25 right here. This was 15, and since it's a rectangle, there's a right angle, and I just did the Pythagorean theorem right here. And when you do, you end up getting 20 for this side. So in order to find the area, I just have to take the base, which is 15, times the height, which is 20. So the total area is 300.